I'm very excited to be here today and present at the Mine Automation and Communication Conference. 3DP was selected as a presenter because we're recognised as a world leader in the field of innovation and thought leadership in mining technologies and applications. The presentation that I'm going to give today is a case study, and whilst it's unique to a specific customer, for us it more or less summarises what is common in terms of goals, objectives and requirements for the industry as a whole. So before I start though, I would like to just give you a brief overview of 3DP, who we are, and what we do as an organisation that is unique, and what it is that has led us to be the solutions implementation vendor of choice for over 80 mine sites around the world, and how we managed to secure global contracts with the largest miners. So without further ado, who is 3DP? 3DP is a team of industry experts. Our background is in the field of development of applications, hardware, support and services. Many of you will know some of these systems already in the mining place. We were the original developers of some of these applications and the hardware platforms that support them. So we have mining engineers, product engineers, application development engineers who all understand the mining application and what it is that's required to support and maintain those applications. So what do? We design and manufacture ruggedized open computing and networking platforms for the mobile mining environment. We research and design complete end-to-end solutions. Our solutions are customer driven in terms of what's required and what the solution needs to look like. We're not a product vendor that produces a product and then goes and finds a market. We're very specific to the mining application. Our track record is testament to that, with thousands of mobile endpoints and wireless networks deployed across 80 or more mine sites around the world. Through consultation and partnership with our customers, we've developed our roadmap and product management vision, and from that is generated this statement that we believe every piece of mobile equipment should have a single open platform to provide computing and communication to all onboard applications. Our story is about integration and management, and be able to make your job easier as a miner to get on with your business rather than technology for technology's sake. This is actually a customer slide from an earlier presentation a couple of years ago, I think in one of these events, where they actually called out the vision that we've aligned with, which is to be able to take a situation that looks something like this inside the cab with multiple applications and disparate systems and turn it into a situation like this. That's our common goal for the mining industry as a whole. So in my case study today, I'm going to talk about the process that we went through with the customer and the consultative approach that we took to solve a number of problems for them. The engagement originally started as a single application use engagement, where the dispatch engineer gave us a call and said, look, we're upgrading our system and we're looking for a comm solution to be able to support the integration of our new system. But through our engagement and further questions, we uncovered that there was actually a number of opportunities that could be leveraged off a common platform. And through that, we drew a larger stakeholder engagement and formed a much deeper set of requirements that addressed the company as a whole and some of the challenges that they were faced with on their day-to-day operations. I'll talk about each of these points in detail. So, in beginning, looking at the upgrade of the legacy dispatch system, what we discovered was there was a corporate-wide policy to actually move to one common system across the organisation. The customer was actually an organisation that had acquired a number of mine sites around the world, and each of them were running separate dispatch systems. So it became a corporate initiative to go out and select best-of-breed application in the space of dispatch, so they could standardise on common reporting methodologies, one version of the truth, so to speak, from every mine. So what they were looking for was a solution that enabled a smooth migration path from their legacy systems through to their standardised systems. So this page really represents what was existing across their various mines around the world. And you can see they pretty much had everything there in terms of dispatch vendor applications. So I can't remember who mentioned it before about the comms system, but they talked about it as being a piece of glue that provided the connectivity between the application and the reporting infrastructure. What the customer was looking for here was indeed a piece of glue that could fill the gap between these disparate systems here and provide them with a common piece of hardware that they could unplug one system and plug in the new one when the time came. They were also looking to implement a machine health monitoring system. The business had already implemented a solution for fixed plant that automated their maintenance and planning processes. And they wanted to find a way to actually implement and integrate that solution into a mobile fleet environment. So the problem in this space is common in that there's, apart from maybe a couple of vendors that have their fixed solution, there's no common vendor that can provide an interface to every different type of machinery. So what they were looking for was a platform that would enable them the development of interfaces for disparate systems. So they were looking for a solution to access data on an onboard mixed fleet. Some of these drawings that I'm showing you here are really reproductions of what the customer was actually providing us as what they were looking for. So as I said, typically what we see here is customer-driven solutions. All we do is listen to what they need and we produce the outcome. So they needed a platform that would enable them to integrate their inspections system using tablets during their pre-start walkarounds, their vehicle health management systems, oil and lube, tyre pressure management systems, and synchronise it with their dispatch systems for service times and things like that. The customer was also working with high precision applications, except some of their sites were still actually operating on legacy UHF systems. For those of you who understand what that means is that for high precision applications, you'll have a GPS antenna on your machine that is providing positional information. And there's a GPS base station somewhere else that is serving as a reference site. And what it does is it broadcasts out across the air on the UHF system correction information, so a differential can be measured and they can understand to a much higher degree of accuracy exactly the position that that piece of equipment is in, whether it be a drilling application or an excavation system. The challenge with UHF systems is that whilst it's a great medium for broadcasting corrections because it has great distance and penetration capabilities, so less requirement on infrastructure, it actually doesn't support the transfer of high volumes of data. So the customer was actually looking for a means to be able to integrate this solution onto their wireless broadband network. So that would enable them to be able to transfer data, upload data to the machines and suck off data for reporting purposes. It answered a number of questions for the customer in that with the transfer of data on and off machines to that volume, it meant that you didn't have surveyors going with memory sticks, driving into the pit, plugging it into the system, uploading the file, downloading the reporting information, going back and post-processing. It was about enabling real-time applications. So this is a picture that sort of more or less shows what the solution needed to be looking like to enable that transition from a legacy UHF system to a broadband system. Here we have the legacy UHF broadcast system with the GPS base station, the transmitter transmitting those corrections coming out from the GPS base station and received at the equipment end, and the differential information is calculated in the application. So what they were looking for was a means to integrate that system into their Ethernet broadband system and also integrate the back-end servers into that to transfer data on and off via the wireless cloud. So again, they were looking for more or less a piece of glue that would solve that problem. They also needed something that would enable the transition of a serial-based interface through this legacy system to an Ethernet-based interface. Some of the legacy systems only had a serial interface that could be connected, so they needed a solution that would actually take that interface and plug it in over here. Some of the newer equipment had an Ethernet interface that would enable them to just make that modern style connection. One of the biggest challenges for the mining operation was the reliability of the solutions that they were running. The GM was pulling his hair out in terms of how the electronics groups and IT groups were building disparate solutions and very bespoke in terms of the way that they were being produced, supported and maintained. They had no tools that gave them visibility of what the performance of the network or the applications looked like. And the business was struggling with the increasing reliability on IT resources that were becoming more and more hard to find to work in the mining environments. So what the customer was looking for was a solution that would enable more resources with less skill sets to enable them to do their day-to-day jobs easier in a less complex manner. And management tools to proactively maintain their networks and applications. In doing an audit of the site, we came across multiple solutions to solve their problems of connectivity and integration. So here is a typical haul track style solution where there's we're very I don't know what the word is for this solution, but it was put together with a dispatch system, a radio. They also had some other integration requirements on board, so they built in a box there to house a network switch, which was, you know, a cheap solution. It allowed them to connect things up. They had to implement a power supply, and in running that solution, they found over time that it would go offline. The IT tech would go on board the machine, pull the machine over, another hour goes by, and find that the power supply blew up. They replaced the power supply, and a couple of weeks later, the system would fail again, change the power supply. Months and months goes by, and they realise that the power supply on a truck is not really a clean power supply. So you need to put in some sort of a filtering device. So, and again, another filtering disparate piece of hardware to overcome a problem. What this produces is more and more points of failure in a system. The cabling, where they've got what is really office-style, solutions, if that, where they're using off-the-shelf joiners to connect up Ethernet cables, multiple connections in the radio links, all of those sorts of things that all compound in the reliability. Here on the shovel, you're looking in a cabinet there on a shovel, they've got multiple pieces of hardware to actually go about solving their integration issues. So as you can see, none of these really look like a built-for-purpose installation. From a configuration perspective, every single solution had a separate configuration profile. There were at least 10 different systems on board various machines, each of which required a specific configuration that looked something like this, which kept the IT people very, very busy. And every time there was a problem in the system or a bug in the programming, debugging this type of thing became more and more complex. So the problem was really about the sustainability of the solution. The goals for the customers really about reducing failures of the onboard networking solution. The current bespoke solutions were, subject to a high failure rate, causing unnecessary downtime. That meant tons for the miner. That's their job, to actually shift tons. It's not to actually build IT solutions, and it's not actually to run an IT department. We rely heavily on IT to give us good business practices in the management of their applications and reporting, but it's not IT's department to actually make homegrown solutions when there are great solutions out there already available. So the customer was really looking for solutions designed and built for purpose, something of a mill standard, a mill spec, for the fleet installs. And the common objective was really about reducing the points of failure. More integration of applications with less hardware. Scalability was an issue for the customer, where whilst they had their common set of requirements, which were really around dispatch, guidance and health of the machinery, the business improvement and safety groups had identified that there were other requirements coming downstream to solve business problems, either from an improvement perspective, reduction in fuel, tyre wear, safety, you name it. They had identified areas of improvement, but had not necessarily identified the applications that they would choose. So they wanted to ensure that whatever solution they went with would enable them the open choice to choose best of breed and be able to integrate that application further down the track. In looking at their networks to support their longer term growth, it was clear that they had an increasing number of wireless applications that required access to the network. What the customer was looking for was a subject matter expert with solutions based on experience and proven success. There was a requirement to actually understand the applications and how to integrate them. Has the solution got a management strategy around those applications? So in summary, what the business was looking for was a common high reliability, built for purpose, open middleware platform. That's an incredible mouthful right there. That can be used across all of the fleet to integrate and manage multiple applications, including their standard dispatch, health guidance, and all of the other business improvement opportunities that they've identified. Again, as I said earlier, some of these drawings were actually given to us by the customer. This is a reproduction of the original drawing that the customer gave us that had all of these different applications plugging into a mine vehicle, except the only thing that they had missing was this in the middle. They had a black box that said integration device. And thankfully, 3DP had that answer already developed. The enabler for them to be able to plug in any of these applications, all or any of these, and give them the answers to enable them to do things like onboard digital video recording, offload of vehicle health information by defining where and when that information would be transferred off, about enabling them to be intelligent about how they manage the transfer of data around their mine. The integration of their existing dispatch and guidance systems, and more. The fact that they could have a solution that provided them with an inbuilt power supply, a radio, an integration layer, plus onboard tool sets that enabled them to manage those applications on a day-to-day basis was of significant importance to them. What the business was also looking for, as I said earlier, was a simplified user interface that could be used by the operational resources, less dependency on the IT resources on a day-to-day basis to enable the integration and management of the mining applications. So we gave them a web-based interface that was specific to the mining applications that they were running, that enabled them to quickly configure and maintain configurations of the onboard systems by selecting the features that they needed to implement and setting up the interfaces on board the equipment. What this means is, I don't know if I've got this slide coming up, but I'll talk about it shortly. What this means is, with basic training, lower level skill sets are able to actually run and maintain systems that are highly intelligent without the need of IT departments. This was significantly important to the customer because we're living in an environment where those sorts of resources are hard to get and hard to keep. So we provide, I don't know if you can see it here, that we've got a number of applications in the feature list here that addresses all of the applications for this particular customer. Aquila CAES, IntelliMine, geolocation information, reference station integration, plus MineStar Health. We provided them the enabling tools for simple integration. Base station integration. This is the config slide that I was showing before. All of these technical configs still exist on the system, but they're in the background. What we've done is automated that configuration so the lower level resources can actually type in from a simple script the basic configuration information like the server IP address and the screen IP address, hit send, and in the background the configuration is compiled and pushed out to the endpoint. So it minimises the risk of error in configuration, debugging, and it standardises the approach for integration. I'll go back, I think I had a slide there. It enables them to actually build templates for machines and actually push a standard template out over to each machine. I've gone the wrong way. Sorry. So coupled with that, with the tools that the customer was looking for to enable them to be able to proactively monitor and maintain the health of the network itself from the mining application perspective. One of the biggest things that we find with service companies that provide IT services in infrastructure and the like is they're very good at managing to an SLA or a contract. And you as the miner just love those sorts of contracts because you've got a problem on site, and I think insourcing was discussed earlier, and one of the drivers behind the insourcing is really about ownership of your network and your applications and the management of them. One of the most common stories I hear is when the guy in the field rings up and said, I can't contact my trucks, they're offline, and the IT guy goes, well, all the access points are up and I can connect to them, so I don't see where the problem is. Goodbye. So what we were looking for is, well, how do we monitor and maintain these sorts of things so we can proactively measure and report on the health of the network? So every single intelligent endpoint on the machines that is implemented is capable of gathering information about the network as the mining truck or dozer or whatever the machine is drives around the mine. And it can collect that data and report on the health of the network from the mining equipment perspective. I don't know that there's any other product out there that provides reporting stats to this sort of level of detail. What's interesting, I love talking about this particular slide because what we've got is a slide that's showing signal strength around this particular portion of the mine. And what's interesting is when the customer was talking to us about this particular slide, they asked the question, how come we've got green colour going in one direction and we've got orange and red going in another direction? And we asked some questions about that. And this goes back to another part of solving the problem from an end-to-end perspective. We asked some basic questions. Tell us about your antenna mounting system on that machine. And they said, oh, well, I don't know. Let's go and have a look. So we took a look at it. And sure enough, what we found was the antenna was mounted out to one side of the truck. A single antenna, one side of the truck. So what that meant was travelling in one distance, we had a great view to the infrastructure. And as the machine turned around, we were masking the actual signal from the infrastructure. We investigated what was going on with the antenna mounting, and we found out a very inconsistent set of results in that some trucks had the antenna in a great position above the headboard and good visibility to all the infrastructure. So it actually reported green in both directions. But some of the machines were reporting different colours in different levels of signal in two directions because of antenna mounting. We found that the problem actually came back to typically end of shift, not enough cable, let's just stick it there. So again, that's more about quality of installs and the end-to-end solution. So the tools enable them to view the access to the network from the client perspective in a number of ways. In this presentation, we've got signal strength. Over here, we're looking at what access point we're actually connecting to. A lot of people think that putting access points all up high is a great idea because it means that you've got good visibility, which is true. But what happens is typically with a wireless client, when it connects to an access point, it likes to stay connected to it for a long, long time. So it's a pretty basic rule of physics. The further the distance, the less your throughput. So in implementing a good design methodology, we advise our customers to work in more or less cells of coverage and try and isolate the coverage areas that your access points have. So, and that enables the client from a truck perspective to be able to go from one zone and hand off into another zone and maintain a good level of throughput. These sorts of tools make it very easy for the customer to identify which access points the mining equipment is able to see at any given point in the mine. And also filter down into problem areas where throughput may become an issue. And it'll help them assess whether they need to put in more infrastructure or just move the infrastructure into a better location. The ability to monitor onboard applications is absolutely vital these days. So we can actually have a view of what the health of the application looks like, what the profile of its requirements looks like. It can help us decide on whether we need to set up some sort of management plan around how we transfer data on and off the machine. Do we need to rate limit some applications that are using up your bandwidth? With these tools, we provide the user with a very quick snapshot of what's available, what's being used, and how an application is performing from the mobile application perspective. All this data is enabled by that one piece of equipment that's on board the machine as part of the integration solution. In terms of upgrading legacy networks, I'd just like to touch on this very briefly because a lot of corporate organisations love to make statements around technology and what should be implemented and what the standard of choice is, and it has to be that. That's not necessarily the answer for every single mine. It's not always the same, and there are certain conditions that drive that, whether it's a lot of mining, other mining customers surrounding your mine, creating lots of interference with similar infrastructure. So you need something like a moto mesh solution, which has frequency agility that enables you to hop around interference zones. Mobile meshing, it's an excellent sales tool for radio vendors. People get caught up on the hype of what meshing means. Meshing from a mobility perspective has a limited set of applications and only in minor areas of the mining operation. Where meshing actually has a benefit is in the infrastructure layer and meshing at an infrastructure level to enable easy deployment of trailers and things like that around the mine without the dependency of lots of backhaul. Now, in terms of that, we also have to talk about deterministic links and how you design an infrastructure properly. So you're not reliant on always one common piece of hardware to solve the problem. 802.11n, 3DP has spent a long time working on solutions based on 802.11n. We started that development work back in 2008. And through our research and development, we've found that there's only one product on the market today that can actually address it reliably from an infrastructure perspective. And the main reason is the distance. Many applications, and I'll be very quick in the description of this, most vendors have vertically polarised transmission streams. 802.11n talks about being able to enable higher throughput with multiple streams of information instead of traditional one stream, multiple streams, and so the receiver receives those. All of the technologies on the market today typically transmit on a vertical plane, And they talk about how great that is because the reflections and all of that sort of stuff bounce around and the receiver receives those multiple streams. Thank you. And, but what happens in an open pit environment is that multiple streams don't exist. When you're 500 metres away or more in the middle of a pit, there is nothing that you're reflecting off. There's no walls, there's no... 802.11n works very well inside a building environment. What we've found is there's a product from Motorola that is one product only that transmits on vertical and horizontal planes. And by just changing that, that transmission methodology, they've enabled distances out beyond 1 kilometre at 802.11n speeds. LTE is a very promising technology from a solution perspective. And indeed, I'm proud to announce we've received our first purchase orders for LTE infrastructure in the Pilbara. In the Pilbara, that's a great opportunity because licences are available. But the restriction in many locations is around licensing, not so much about the technology. So it really is assessing the value of particular technologies and the viability for your given region and location and operation. So in summing up, the future state for the customer is more about integration through one common piece of middleware. More application vendors are licensing applications to us and allowing us to host those applications natively on board that common piece of hardware. So by doing so, enabling our vision statement, moving from this to this. So today, we typically integrate those disparate systems and plug them all in and provide management tools for those applications, reporting, and the capability to be able to scale. Tomorrow, as we license more applications for onboard applications, we'll be reducing the clutter from the cabs, producing outcomes on a single screen basis, sharing GPS correction information across all of those applications, and therefore reducing the amount of antennas on trucks, allowing the integration of those video streams, the recording and management of those. Thank you very much.